Next topic is the VSPER theory. It is the valency shell electron pair repulsion theory is known as a VSPER theory. In the year of 1930, Sidgwick and Powell had introduced this VSPER theory. After that, in the year of the 1957, Nyholm and Gillespie again they further developed this VSPER theory. So, this theory mainly explains the based on the valency electrons. Means, for example, we take the 1s2, 2s2, 2p, 5 or anything. So, here it is the valency shell. It is the central nucleus, it is the 1s and it is the 2s and 2p. So, here the electrons present in this valency shell, okay, the theory mainly explains the based on that electrons present in the valency shell. So, here we see this theory is useful to explain the shape and geometry of the molecules. So, here that electrons mainly here it explains depending upon the bonding electrons means number of electron pairs, and also here that electron pairs, these are the bonded electron pairs or the lone pair of the electrons. We take one example. X, it is a central nucleus, okay, and here this Y is attached to this central nucleus. So, here in between these two, here two electrons are there. So, here the bond is present in between this X and Y, means here these two electrons are shared in between the two nucleus of the atoms, okay, one is the central atom and another one is the bonded atom. So, otherwise here it is the lone pair of electrons, okay, it is the lone pair of electrons. Here it occupies only the nucleus of the central nucleus, but not the bonded, okay. Here electron pairs, these are shared in between the two nucleus, one is the central nucleus and another one is the bonded. But the lone pair of electrons, it is shared with only central nucleus. So, automatically what happened here? This lone pair of electrons, they occupies the more space. So, they occupies the more space means slowly here distortions are takes place. Means here that repulsions are takes place. For example, we take the NH3. In this NH3, this nitrogen is attached with 3 hydrogen atoms. Okay. So, here it is with one lone pair of electrons. Generally what happened? This lone pair of electrons, they occupies the more space. So, they occupies the more space means what happened? Automatically here the bond distance in between these 3 bonded electrons are automatically decreases. So, due to the presence of this lone pair of electron here in this NH3 here, it shows the distortions. Okay, you understood? Here the lone pair of electrons, they occupies more space than compared to the bonded electrons. So, due to that reason here it shows the distortions. Okay, means here it shows the repulsions. So, here it shows the repulsions means automatically here in which bond angles and shape is also changed. In VSPER theory here it is explained that molecule it is 2 types. Okay, here that molecule it is 2 types, in which one is the molecule there is no lone pair of electrons, and next one the molecule it is with lone pair of electrons. Okay, here molecule it is with lone pair of electrons and another one is the lone pair of electrons. Okay, these 2 type of molecules are involved in that VSPER theory. So, here we see the, according to this VSPER theory, we see the electron pair. So, that electron pair it is maybe bonded electron pair and lone pair of electrons. It is the electron pair. So, here it is with 2 electron pairs. So, here the 2 are the bond electron pairs. Okay, these two are the bonded, means here there is 0 lone pair of electrons. At that time here it shows the linear shape. Example is the BCl2. It shows the linear in shape. And next here that electron pairs are 3. So in that 3 here, the 3 are the bonded electron pairs. Okay, 3 are the bonded electrons, means here the lone pair of electrons are 0. So at that time here it shows the trigonal planar. Shows the trigonal planar in shape. So then here example is the BCl3 is the example of this compound. And next here that electron pairs are 4. Okay. So here that 4 are the bonded electron pairs. So lone pair of electrons are 0. So then here it shows the tetrahedral shape. Tetrahedral shape. And here example is the CH4 molecule. And here that electron pairs are 4. So in which 3 are the bonded electron pairs. So then 1 is the lone pair of electron. So at that time here the example is the trigonal shape is a trigonal bipyramidal. So here example is the NH3. Okay, this NH3 it is with the 1 lone pair of electron. And next here the electron pairs are 4. In that 4, 2 are the bonded electron pairs and 2 are the lone pair of electrons. So then here it shows the bent shape or V shape. It is with bent or V shape. So example is the H2O is the example. Okay, here in these 3 examples, the total electron pairs are 4. So that 4 are the bond electron pairs, then it shows the tetrahedral shape. And in that 4, 3 are the bond electron pairs and 1 is the lone pair. Then here automatically here its shape is changed. Okay, here it changed to tetrahedral to trigonal bipyramidal. Why? Because here in which distortions are takes place. Okay, due to the presence of 1 lone pair of electron, here it shape is changed. And next we see the in that 4 electron pairs in which 2 are the bonded electron pairs and remaining 2 are the lone pair of electrons. So then here it shows the V shape. Okay, in these 3 examples here the total number of electron pairs are 4, but in which that 4 are the bonded electron pairs. There is no any lone pair of electrons. So then it is the tetrahedral in shape. So here it is with 1 lone pair of electrons. So then it is the trigonal bipyramidal. Example is the NH3, that is the ammonia. And here it is with 2 lone pair of electrons. Then automatically it change its shape. So that is bent or V shape. Example is the H2O molecule. And next we see the some more examples here. It is with 5 electron pairs. Okay, these 5 electron pairs, these 5 are the bonded electron pairs. There is no lone pair of electrons. Then here it shows the square planar shape. Okay, here example is the PCl5 molecule. And here in which 5 electron pairs here, 4 are the bonded pair electrons and 1 is the lone pair of electron. So then here it changed its shape to seesaw shape. Okay, it is the seesaw shape. In this 5 here, in which 3 are the bonded electron pairs and 2 are the lone pair of electrons, then here it shows the T shape. Means simply here this VSPER theory is explain the shape and geometry of the molecules. Due to the presence of the lone pair of electrons, here the shape of the molecule is changed. Mainly this VSPER theories and geometry of the molecules, especially about the p block elements, means large size molecules. It is about the VSPER theory.